Hello guys, welcome to this video series on parallel and distributed algorithms. In this series, we will explore how modern computing leverages the parallelism and distribution to enhance the performance. From basic techniques to the advanced problem solving strategies, we will break down the complex concepts into the simple explanation. We will cover the message passing, pipelining, synchronization, load balancing and distributed memory systems. So whether you are a beginner or preparing for exams, this series will guide you step by step. Okay, so parallel and distributed computing is at core of high performance computing, cloud computing and AI. By the end of this course, you will understand how algorithms are optimized for large scale systems. We will also explore the real world applications and practical programming tools like OpenMP. So get ready to dive into the fascinating world of parallel and distributed algorithms. At first, introduction to the parallel and distributed computing. Parallel and distributed computing deals with executing the multiple tasks simultaneously to improve the computational speed and efficiency. Parallel computing involves dividing the task into the subtasks and executing them concurrently on multiple processors. Distributed computing, on the other hand, connects the multiple systems over a network to work together on a problem. Modern applications like cloud computing, AI, and large scale simulations rely heavily on these techniques. Parallel computers can be classified into shared memory and distributed memory architectures. Cluster computing is an example of distributed computing where multiple machines collaborate for high performance. Key advantages include faster processing, scalability, resource efficiency. However, challenges like synchronization, communication overhead, and load balancing must be addressed. So, efficient algorithms ensure proper task distribution and execution to maximize the computational power. Understanding the basics of parallelism and distribution is crucial for solving the complex real world problem. So now, basic techniques in parallel computing. Parallel computing uses various techniques to break down the tasks and execute them efficiently. One fundamental approach is task parallelism, where different tasks run independently on multiple processors. Another technique is data parallelism, involves applying the same operations to multiple data elements simultaneously. The efficiency of parallel computing is measured using speed up, efficiency, and scalability. An ideal parallel system reduces the execution time while also parallelly utilizing the resource effectively. Popular architectures included SIMD, MIMD, single instruction multiple data, and multiple instruction multiple data. Parallel computing also introduces the challenges like the race condition and deadlock, which we already know from operating systems concept, which must be managed. Synchronization technique like barriers and locks help to maintain the consistency in the shared resources. Developers use frameworks like OpenMP, MPI to write the efficient parallel programs. With parallel techniques, we can optimize the computations in the fields like the machine learning, cryptography, and simulation. So now, message passing and debugging in distributed system. Message passing is a critical method for communication in the distributed system where tasks run on separate machines. It involves sending and receiving the message between the processes to share the data and coordinate the execution. The message passing interface MPI is a widely used library for writing the scalable parallel programs. A major challenge is ensuring the efficient communication without excessive overhead. Blocking and non-blocking message passing are two key approaches, balancing the performance and synchronization needs. Debugging the parallel program is more complex than sequential debugging due to concurrency and synchronization issues. Tools like the GDB, Valgrind, and MPI debugging libraries helps to detect and resolve the errors. Evaluating the parallel programs involves measuring the execution time, efficiency, scalability. Partitioning strategies like the static and dynamic partitioning help to divide the workload optimally. By effectively using the message passing, distributed systems achieve the fault tolerance and high performance. So number 4, Pipelining techniques in parallel computing. Pipelining is a technique where different stages of tasks are executed in parallel to improve the efficiency. It is widely used in computer architecture, instruction processing, and parallel programming. A pipeline consists of multiple stages, you can say, where each stage processes a part of task simultaneously. For example, in a 5-stage CPU pipeline, instruction pass through the fetch, decode, execute, memory access, and write back. Pipelining enhances the throughput, allowing multiple tasks to be processed at the same time. However, challenges like the pipeline stalls hazards can reduce the performance. To optimize the pipelines, techniques like the branch prediction, instruction recording are used. In parallel computing, software pipelining helps to execute the loops efficiently by overlapping the iterations. Pipeline models are widely used in image processing, deep learning, and parallel numerical computations. So, by leveraging pipelining, we can significantly speed up the execution without increasing the resource uses. So, now synchronization and load balancing in distributed system. Synchronization ensures that the parallel tasks execute in a coordinated and consistent manner. Without proper synchronization, issues like race condition and data inconsistency can arise. Techniques like the locks, semaphores, barriers helps to manage the shared resources effectively. Load balancing distributes the task evenly among the processors to prevent the bottlenecks or underutilization. It can be static or dynamic. Efficient load balancing improves the system's scalability, responsiveness, and fault tolerance. Distributed termination detection ensures that computations halt when all tasks are completed. Parallel programming languages like the OpenMP, you can visit OpenMP official website also in Google. So OpenMP provide the constructs for shared memory programming. Using shared memory multiprocessors, we can achieve the high performance with data parallelism. Techniques like the thread synchronization and memory consistency models, this ensures the correctness in the shared memory system. So now, distributed shared memory and parallel algorithms. Distributed shared memory or DSM, it allows multiple processors to share the common memory space across a network. It simplifies the parallel programming by providing a global address space without direct message passing. DSM systems implement the page-based, object-based, and variable-based memory models. A key advantage is scalability, as DSM enables the high-performance computing without expensive hardware. Parallel sorting algorithms like the parallel merge sort, parallel quick sort improve the sorting speed significantly. Similarly, parallel numerical algorithms are used for matrix operations, simulation, and scientific computations. Using distributed memory programming, large-scale data processing in the cloud environment become efficient. Programming models like MPI, OpenMP provide the robust framework for parallel computing. The future of computing relies on parallel and distributed architecture for AI, big data, and quantum computing. By mastering these concepts, you will be prepared for high-performance computing and research innovation. So that wraps up our video on parallel and distributed algorithms. We covered fundamental concepts like the parallel computing, message passing, synchronization, and distributed memory. Understanding this concept is crucial for working in the cloud, AI, and high-performance computing. In the upcoming videos, we will dive deeper into each chapter with real-world examples and coding demonstration. If you found this video helpful, so like, share, and subscribe for more educational content. Drop a comment below if you have any doubts or specific topics you had like me to cover. Parallel and distributed computing is shaping the future of technology, so stay ahead of the curve. Make sure to check our next video where we will begin with Unit 1, the basic techniques in the parallel computing.